Hello everyone. Today we're gonna have our final report on artificial intelligence term project, and our member have me and Zhang Yueyang and Huang Youting. Yeah, just our two. And today our report is gonna to have introduced about the image segmentation and fully convolutional networks about for the segmentation and deconvolutional and about UNet and SegNet, and I'm going to report the image segmentation and the FCN and the deconvolunet. Yeah, and Youting is gonna to report the UNet and the SegNet. And first of all, we're going to I'm going to introduce the key about the image segmentation techniques. Yeah, and there is the three type of the segmentation, and the first one is the semantic segmentation. It categorizes each pixel and crucial in medicine for diagnostics and in autonomous systems for real-time object recognition. And the second one is the instance segmentation. It takes it further by distinction individual instances, ideal for the video post production and precision takes in the robotics. Yeah, and the third one is the panoramic segmentation. Yeah, this one is it's used in the robotics and surveillance and virtual reality for immersive experience. Yeah. So these three about in the conclusion, these techniques reshape computer vision, impacting medical diagnostics, autonomous systems, and immersive environments. Thanks for this quick journey. Yeah. And there is two commonly used application of the image segmentation, and there are the first one is medical image segmentation. In medical image segmentation, precise delineation of structures, organs, or abnormalities is crucial for diagnostic purpose and treatment planning. It plays a vital role in identifying and localizing tumor, analyzing organ structures, and aiding medical professionals in making informed decisions. And the second one is the autonomous driving. Image segmentation is fundamental in autonomous driving systems to perceive and understand the visual surrounding. It is utilized for the identification and classification of the objects such as pedestrians and visuals and road signs. This technology enables autonomous visuals to safely and make real-time decision based on the segmented visual data. Yeah. And the paper I'm going to introduce about the FCN is authored by the John Dan Long, Evan Shelhamer, and Trevor Darrell. It was originally published as the Converse on computer vision and pattern recognition in 2015. The paper introduced the fully convolutional networks architecture, a pioneering model in semantic segmentation. And the architecture about the FCN, first one is the key component. As FCN diverges from traditional convolution neural networks by replacing fully connected layers with convolutional layers, preserving spatial information. It compresses an encoder and decoder structure, with the encoder extracting features and the decoder performing pixel-wise classification. Second is semantic segmentation. I have said it before. The FCN excels in semantic segmentation, enabling pixel-level classification in images. It employs skip connection to fuse multi-scale features, enhancing the model's ability to capture both fine and coarse details. And about the application about the FCN, its flexible architecture accommodates variable input sizes, making it applicable in diverse domains such as the computer vision, medical imaging, and autonomous systems. And the FCN's advancement is the evolution of FCN includes variants like UNet and DeepLab, each addressing specific challenge and pushing the boundaries of segmentation. So the conclusion is the FCN's architecture revolutionizes image segmentation, providing a versatile and powerful tool for diverse application, marking a significant leap forward in the field. Yeah. There is important things called a deconvolutional base. It refers to a type of neural network architecture used in tasks like image processes and computer vision. In instances, it involves the use of deconvolutional layers or transposed convolutional layers, which work in the reverse direction of standard convolutional layers. This architecture is particularly useful in tasks such as image upsampling and generating high-resolution images from low-resolution inputs. Deconvolutional bases play a vital role in tasks requiring the reconstruction or expansion of feature maps, contributing to advancements in image synthesis and enhancement. And the disadvantages of fully convolutional networks. Its drawbacks include high computational complexity, reduced spatial resolution, fixed size input requirement, blurry object boundaries, challenges with irregular shapes, and the demand for the extension annotated data. Researchers aim to address this limitation for enhanced image segmentation. And the last one, we're going to talking about the deconvolution network of segmentation. The paper we used is authored by the Hyeonwoo now and Seunghoon Hong and Bohyung Han. It was published in the Proceedings of the IEEE Converses on Computer Vision and Pattern Recognition in 2015. This work introduced a deconvolutional network of semantic segmentation, contributing to advancement in computer vision and image understanding. The paper Learning Deconvolution Network of Semantic Segmentation by Hyeonwoo Hong, Seunghoon Hong, and Bohyung Han introduced a novel deconvolutional network for precise semantic segmentation. It leverages deconvolutional layers for efficient upsampling, with a notable emphasis on the innovative unpooling technique to preserve spectral information lost during pooling. And the deconvolution network comparison with FCN, this approach distinctively focused on the unpooling method, while FCN pioneered pixel-wise classification. The learning deconvolution network refines this process by enhancing upsampling, leading to improved detail extraction for segmentic segmentation. So, in this conclusion, this paper represents a significant stride in semantic segmentation, the purpose deconvolution network, particularly with its emphasis on unpooling. Yeah. And this is all about my report, and we have the question and answer. Yeah, thank you.
The second lecture review called UNET Convolutional Network for Biomedical Image Segmentation. And this paper is from Medical Image Computing and Computer Access Evaluation MICCAI in 2015. Next is the UNET architecture. The UNET architecture has semantical encoder and decoder section. The encoder downsampling, while the decoder upsampling. There is a skip connection between the two, which means the features between the corresponding encoder and decoder layers are combined, which help the model obtain more accurate position information. And next is the UNET encoder-decoder architecture characteristic. And first one is skip connection. And skip connection in the UNET are employed to address the challenge of information loss during downsampling and upsampling in image segmentation tasks. This connection helps merge features from different resolution levels, enhance the model's ability to capture fine details. And second one is decoder. The decoder is putting the extract pictures back to the size of the image that had original intent. You want to explore their detail were on the image. The third lecture review called SegNet, a deep convolutional encoder-decoder architecture for image segmentation. And this paper is from IEEE Transition on Pattern Analysis and Machine Intelligence. And the next, this is the SegNet encoder-decoder architecture. The encoding network is the same as the convolution network of VGG16, and a fully connected layer removed, and the decoder performs nonlinear upsampling of the input feature map using the max pooling instance received from the Corey pooling encoder. Next is a pooling index, also called decoder, and the decoder upsampling and convolution are performed. At the end, there is the softmax classifier for each pixel, and during the upsampling, the max pooling indices at the corresponding encoder layer are recalled to the upsample as shown above. Finally, a K-class softmax classifier is used to predict the class of each pixel. And what is the SegNet FCN encoder calculation? The SegNet retains the position information during the pooling and directly placed in the data at the original position during the upsampling, while FCN uses the deconvolution plus bilinear interpolation for each pixel in the result of the operation. What's the difference from the UNet? First, UNet is used for biomedical image segmentation. And second, instead of the usage of pooling index, the entire feature map is transferred from the encoder to the decoder, and then convolution is performed via concatenation. And third is this can make the model larger and require more memory. And this is our lecture review. Thanks for watching.